Imagine a semicircle with a diameter labeled AB and a point C resting somewhere along its curved outer arc. From that point C, we drop a straight line down so that it hits the diameter perpendicularly at a point we'll call P. We are given two specific measurements. The distance from the left edge of the diameter to this dropping point, AP, is 9 units, and the height of the perpendicular line itself, CP, is 12 units. Our goal is to calculate the exact area of the small, crescent-like region trapped between the straight chord AC and the curved arc AC. To solve this, we first need to figure out the overall size of our semicircle. We can find the missing right side of the diameter by using a classic geometric rule. The square of the perpendicular height must equal the product of the two split segments on the diameter. Squaring our height of 12 gives us 144. Dividing that by 9 reveals that the missing segment, PB, is 16 units long. Adding 9 and 16 together gives us a total diameter of 25, which means the radius of our circle is exactly 12.5 units. Now, we need to find the central angle that opens up to our arc. Let's look at the center of the circle, which we'll call O. The total distance from the left edge to the center is our radius of 12.5. Since the first segment takes up 9 units, the remaining distance from the center to the foot of our perpendicular line is 3.5 units. This forms a neat right triangle inside the circle where the base is 3.5 and the hypotenuse is the radius of 12.5. Dividing that base by the hypotenuse gives us a cosine ratio of 7/25. Taking the inverse cosine of this fraction gives us our central angle, which is roughly 1.287 radians. Finally, we find our target area by taking the whole wedge-shaped slice of the circle and subtracting the inner triangle. The area of the entire slice is 1/2 of the radius squared times our angle in radians, coming out to roughly 100.55 square units. The area of the inner triangle is just 1/2 of its base, the radius of 12.5, times the vertical height of 12, which equals exactly 75. Subtracting 75 from our total slice leaves us with a final enclosed area of approximately 25.55 square units.